Hello my dear students, I am B.S. Pandey. Today we are in lecture number 25 of chapter 2, section Electrostatics. Okay my dear student, in last class we were studying about the dielectric. I hope you must remember. Okay my dear student, about the dielectric. Today we will continue from there. Student, we have studied if this is plate of capacitor, electric field given. So the dielectric there was negative charge induced and here positive charge induced. Remember, there will be no net change in charge. Only the charge are induced but no net change in charge. Here, suppose plus sigma of this plate and minus sigma of this plate. What you will see, the electric field we have given in this direction, it was the E external, one electric field, and one electric field induced in this direction. In this direction, E external, and in this direction, E induced. Okay, and then we had net electric field. But what about this charge? This charge is called induced charge. Okay, so sigma induced we will write here. This is the sigma induced. This is plus sigma induced and this is minus sigma induced, my dear students. Okay, for this particular material we have also considered one component. It was the dielectric constant. Okay, that must be remembered. Now net electric field we have written due to medium, it was E external minus E induced. I hope you remember. With this formula we have conclude last lecture. So this is E external, sorry, the E net, that is in presence of medium, it was E external minus E induced. Now we can write E external, that is the electric field we have given, and due to this plate electric field induced, so we can write that electric field as sigma by epsilon naught. I hope you remember, within this metal plate the electric field will be sigma by epsilon naught minus electric field due to this particular medium will be what? Of course, sigma induced by epsilon naught, and this is the electric field in medium. Okay, so we can also write this electric field which is in medium. It is nothing but the electric field in vacuum, which is equals to this one but k times. Okay, this is k times, it is k times the electric field, 1 by k times the electric field in vacuum, and this can be written as the sigma by k epsilon naught, sigma by epsilon naught minus sigma induced by epsilon naught. This epsilon naught can be cancelled out, and then we will have a very fantastic formula. It is sigma by k is equals to sigma minus sigma induced by, sigma induced. We have to find actually sigma induced, and this can be written as the sigma induced can be written as the sigma minus sigma by k, or sigma induced is 1 minus 1 by k. The sigma is nothing but the charge induced by area, and this is the charge by area of the plate. Here the area of dielectric and the plate are equal, and the charge induced over this one, it is q induced, and charge over this plate is q. 1 minus 1 by k. So q induced can be written as the q times 1 minus k. If you will be asked to find the induced charge, remember this is induced charge not on the plate, this is the induced charge on the surface, that is the edge of dielectric material. It will be q induced equals to q times 1 minus 1 by k. Now if you will place different type of material, how this induced charge will differ, you can analyze this one. Okay, that's very important. Now actually how we will use this formula in our numerical question, we will study. Okay, now the important use of this dielectrics, student, either you can write in your notes, I'm telling you, okay, because to write over this board is not I think good, you can write. Okay, the first use of dielectric, remember, uses of dielectric, it is the first use of dielectric. Remember, it provides support to the conducting plates of capacitor. Provide support to plates of capacitor. If you will not insert a dielectric between the plates of capacitor, both the plates will, that will stick, and the net charge will be zero. There will be no electric field between the plates, and no capacitance can be considered. Okay, now the next, some dielectric material, student, remember, the some dielectric material which has a higher dielectric strength than air are used to prevent breakdown. Remember, try to write down this one. Some dielectric materials which has higher dielectric strength than air are used to prevent breakdown. Okay, electric breakdown. This is the second use, to prevent electric breakdown. Electric breakdown. Okay, next use, my dear students, you can write, it is to increase the capacitance. As you can see the capacitance, that is the for parallel plate capacitor, what we have written the capacitance of parallel plate capacitor, it was C is equals to epsilon naught A by D. Okay, and we have studied, we'll replace this epsilon naught by K times epsilon naught if medium present. So due to insertion of dielectric, we will derive, okay, we will derive shortly. Due to insertion of dielectric, the capacitance will be K times epsilon naught A by D. We'll derive this one. So the third very important use of dielectric is what? To increase the capacitance. Okay, to increase the capacitance. So these are the basic uses of dielectrics. Okay, my dear student. Now, my dear students, we are going to discuss about the polarization. Okay, it is mentioned in your NCERT. Actually, my dear students, the dielectric we are studying over here, there is only one type of dielectrics in your NCRT given. It is the linear isotropic dielectric. Don't be confused. Last year, CBSE has given a specific word, the linear isotropic dielectric. The number of students were confused. Actually, what is the question? But the question was simply, you have to discuss the capacitance due to insertion of dielectric. Not the very tricky question was there. In a very simple one word, it is mentioned in NCRT. And better that to get good marks in board examination, even the NEET medicals, you have to cover, you have to get command, you have to be very much commanded over the NCRT book. Okay, student. Okay, now we'll discuss about the polarization. Literary meaning of polarization, I have told you already, to arise the pole. But how the pole will arise? Suppose this is a plate of capacitor and you have given dielectric between you have filled dielectric between the plates of capacitor, and the here dipole are arranged here in this way, in random manner. Due to thermal agitation, they moves here and there. These are red color I have been represented over here. It is the dipole moment of individual atom. But when you will switch on the electric field, what will happen? All the dipole start aligning. Okay, start aligning, and they start aligning in the direction of external applied electric field. Okay, the applied electric field in this direction. Am I clear to everyone? This is external electric field, remember. And if dipole is aligned, I am discussing here the one dipole. If dipole is aligned in this way, this is the direction of dipole moment, and we know that direction of dipole moment from negative to positive. Okay, if this is the direction of dipole moment, if dipole is aligned in this direction, then what will happen? The direction of induced electric field, E induced, in this way. It means, as we know that induced electric field will be opposite to the applied electric field. It means the dipole will align in the direction of applied electric field. So the alignment of this dipole, remember the alignment of dipole moment, alignment of dipole moment due to external, this is the external electric field. Actually, the alignment of the dipole moment of the permanent, or you can say the induced dipoles in the direction, okay, in the direction of the applied electric field is called polarization. This is the very simple definition. I'm repeating, you can write the definition, my dear students. The alignment of the dipole moments of the permanent or induced dipoles in the direction of applied electric field is called polarization. Okay, now we will write it mathematically. Mathematically, it is defined as the dipole moment per unit volume. Remember, okay, mathematically it is defined as, it is represented by P, is a vector quantity. We are using here the P for the polarization. Okay, my dear students. So it is mathematically, it is defined as the dipole moment per unit volume. Net dipole moment per unit volume, and this is the polarization. Here P I am using for polarization. Okay, P is polarization. Sometimes it is also called the polarization vector. This can be also written as in some books, polarization vector. Don't be confused. Okay, this is the polarization vector. For linear isotropic dielectrics, remember, for linear isotropic dielectrics, this polarization directly proportional to the external field. This polarization is directly proportional to the external applied electric field, and this is compensated by a constant. It is called xi e, and this xi is nothing but the electric or this is the characteristics. Remember, this is the characteristic. Okay, characteristics of what? Characteristics of dielectric material. Okay, characteristics of dielectric material. This is also called you can say a this is also called electric susceptibility. Electric susceptibility. Okay, this is also called the electric susceptibility. This will decide how much electric field and how the orientation and how fast the orientation of electric dipole moment of any material should be. This is the electric susceptibility, xi. Okay, xi e. The same quantity you will study in magnetism also. That will be the magnetic susceptibility. Here we are using the electric susceptibility. Okay, and this is the relation. If you will be asked in examination, you can use this relation. It is mentioned in your NCERT. I'm not beyond NCERT. I'll stick to the NCERT, my dear student. Okay, so this is the polarization and polarization vector. So this is all about the dielectric and polarization. Now nothing much we have to discuss about the dielectric and polarization. Okay, in this section. Now we will study how this dielectric, okay, how this dielectric changes the electric field potential or the capacitance of capacitor. Okay, my dear students, I'm rubbing this. Now I'm going to derive here mathematical formula for the capacitance of parallel plate capacitor due to insertion of dielectric. You can write the question also. The same question has been asked in board. Derive mathematical expression for the capacitance of parallel plate capacitor due to insertion of dielectric of thickness T. Okay. Now, so the capacitance due to dielectric slab of thickness T. We will generalize. Okay, we will generalize our derivation so that we can use this particular formula in all cases. I'm not here filling up completely the dielectric within the plates of capacitor, but I am just giving you if certain space is being filled by the dielectric, then what will be the capacitance. Okay, my dear student, so this is the capacitor which is connected by positive and negative terminal of the battery to apply electric field, and this is the dielectric slab. Remember, you must have remember the space, two space, this dielectric of thickness what, T. Okay, if the total separation, if the separation between these two plates is D, how much, if it is D, then what will be the length of free space? This is the space where the medium of dielectric is K. What is the length of free space? The length of free space will be D minus T, because in length T we are having the dielectric of, okay, dielectric constant K. So length of free space is D minus T, that is this one and this one. If you will think to derive, you have to just keep in your mind the two or three things, that is very simple derivation, nothing is to be do. Remember, here the electric field will be what, electric field due to free space. Here the electric field will be what, electric field in this particular medium, and net electric field will be changed. Now the potential, here the potential will be what, potential due to free space. Here the potential will be what, potential which is in medium. Net potential what, net potential V will be potential which is in free space, that is V naught, plus potential which is in dielectric. This is the net potential. Okay, I hope this is very clear. Since we have to derive the capacitance, we know that we need potential. So we are proceeding from here only. V. Now V naught. So the V naught potential, we know that the for potential, the formula we know already. The formula of potential, it is V E equals to V by X, or V can be written as the E times X. Okay, so this V naught can be written as V E naught, and this length of free space is what, D minus T, plus Vm can be written as the Em times length of medium is how much, T. I hope you understand. Now this can be also written as the E naught D minus T plus this Em can be written as E naught by K times T. How this E naught by K say? We know that electric field in medium will be 1 by K times the electric field in free space, that is in vacuum. So this will be written as this one. Now E naught, this is the electric field, remember, E naught can be taken as the common, and it is D minus T plus T by K. This is the potential, and this is the potential and electric field. Now leave it by mentioning this is the equation 1. Now potential. Remember student, this electric field can be also written as, so you can proceed by one more step. This E can be written as the sigma by A epsilon naught. Do you remember? Sigma by electric field, it is Q by A. Sigma by, this is the electric field between the space of capacitor. So between the space of capacitor electric field, we know that the Q by A. You can also write here the Q by A epsilon naught D minus T plus T by K. Now this is equation 1. For capacitance, you know that for capacitance, that is the capacitance of parallel plate capacitor. For capacitance we can write, okay, by the same ink I'm writing. For capacitance, Q is equals to CV. So the Q is equals to C and V is Q by, from this equation, A epsilon naught D minus T plus T by K. So the C is epsilon naught A by D minus T plus T by K. And this is the capacitance of parallel plate capacitor in presence of dielectric slab of thickness T. This is the very important formula, my dear student. Okay. In examination, if such type of derivation is being asked, then you can write the D, the separation T, the thickness K, the dielectric constant. Okay, all the legends you can write. This is the derivation. You can see in only one go we have been derived over the one sheet of your board. This is not very difficult. First, you have to write here the net potential. Second, after concluding the potential with the equation 1, second and final, you have to write the capacitance, and capacitance Q equals to CV. Here V already you have been derived. Put the V, you will get the capacitance. It is the epsilon naught A over D minus T plus T by K. Now you can generalize this one, or you can get special cases of this particular derivation. Okay, my dear student. Suppose if a capacitor is completely filled, okay, completely filled. Here the thickness of dielectric was T, but if the capacitor, case 1, if capacitor is filled with dielectric, okay, my dear students, of dielectric constant K, the same. It means this is the capacitor and it is completely filled with dielectric. So in this case, the separation is D, and T will be equals to how much? D, dielectric constant K, plate area A, separation D already we have been taken. Okay, my dear student. So what will be the capacitance? Here T is equals to D. This case is giving you the condition T equals to D. We know that C is equals to epsilon naught A by D minus T, and T will be equals to how much? It is D plus T by K, that is D by K. Cancel out. So C is K will be above K epsilon naught A by D. Had we discussed this one? Yes, we had discussed this one, K times epsilon naught A by D. That is, if dielectric filled, completely filled inside, in between the plate of capacitor, then capacitance will increase by K times. You can see it is increased by K times. Okay, my dear student. Suppose I am giving you the another simple case. Okay, this will be your classwork. If this dielectric, if will just filled the dielectric halfway and the half is free, what will be the capacitance of such capacitor? It is connected with the positive negative terminal. Okay, the entire thickness, that is the separation, is D, and here the thickness of dielectric is D by 2. This is D and this is D by 2. That is the thickness of dielectric. What will be the capacitance? All the required quantities are same. That is the plate area and etc. Could you write? If you can write, then write the answer. Okay. is very simple. You have to just put all the quantities in this formula. Epsilon naught A divided by D minus T will be how much? D by 2 plus D by 2 by K, and then you will have the answer. Okay, my dear student. So you can solve such type of question. Today we have finished with the capacitance if dielectric insert between the plates of capacitor. In next class, we will try to start the combination of capacitor, and then we will study a few standard question by inserting the dielectrics. Thank you, students.